Hello. So today I'm here to just give you a quick overview of my senior capstone project, the use of machine learning in AI general intelligence. So, the initial idea was that human-centric UIs could be automatically converted into a abstract representation more suitable for use by AIs, using machine learning and image manipulation techniques. They chose for this project to use Tetris due to its long history for use in machine learning projects. Now, the initial idea was to split the data into the three most important categories: the state of the game, the incoming tetraminos, classifications, and any of the information presented in the text elements. This would then be regathered at the end of the program into one abstract representation. All this done by packaging coordinator, coordinating and packaging. Now, first step is grid scan, which is able to make a abstract representation of the game, or at least get the information needed to make that, such as the number of columns and rows in the actual grid, as well as the size of tetraminos and bounding boxes for important information. Starting with the initial game, we first apply canny edge detection to isolate the most important edges, from which we're able to calculate where the grid and next is. After that, we are able to then calculate the space of a single grid space by applying canny edge detection to just the grid. From there, we need to go on to identify, as we now have the bounding boxes for next, as well as the bounding box for incoming tetraminos at the top of the screen, which we can also use to divide next. Images are automatically cleaned up with ImageMagick and then passed off to image classification, which uses a convolutional neural network that has been trained using various tetraminos from other implementations of Tetris. There is a complication, however, that after the distortion from cleaning up the image and resizing it to be 100 by 100 pixels, the convolutional neural network, which previously had a very modest accuracy of 75, now is much less reliable. As you can see, instead of Z, L, and J, it has predicted T, L, and Z, which is much less than 75% accuracy. So, for future work, I would like to test this across more UI implementations of Tetris to refine the parameters and methods used. I'd also like to test it with a custom-built AI. I also would like to bring back the dropped idea of using these text elements, as though they may not be important for the AI, they do let us determine where elements of the UI are when finding their bounding box, so knowing these things would be helpful. I would also like to expand the data set, as in hindsight, a lot of the reliability issues have come from having far too small of a data set. Thank you for watching this video.